Hi, welcome back. I am super excited today because we get to talk about one of my favorite topics, which is inference forms. Inference forms is going to be our first step into symbolic logic, and that will involve evaluating inferences by applying particular rules to them. So far, we have only one way to evaluate inferences, and it's the Bob method. The Bob method has one huge advantage and one disadvantage. The huge advantage to the Bob method is that we can use it on any inference. I don't care what inference you're looking at, you can always ask, if Bob, a perfectly gullible, perfectly rational person, believes the reasons here, how likely is Bob, perfectly gullible, perfectly rational person, to believe the conclusion? So that generality is incredibly useful. The problem, though, is it requires us to model what a perfectly rational person would think when we are not ourselves perfectly rational. So we are apt, under certain circumstances, to make mistakes. We will think that a perfectly rational person will believe the conclusion when they won't, or we will think they won't believe the conclusion when they would. So, Bob method, perfectly general, subject to failure under particular circumstances. The inference evaluation method that we are about to learn has kind of complementary advantages and disadvantages. The disadvantage is that it's not applicable to each and every inference, at least not easily. It's only applicable to arguments or inferences that have particular shapes, and that will make more sense to you as we go on. But the huge advantage is, once you learn it, you can apply it and you will not make any mistakes once you really have it, kind of tattooed on the inside of your scalp. So it's complementary, right? The benefits and disadvantages to that of the Bob method. The big advantage is kind of foolproof. It's not subject to error unless you just happen to forget a rule. The disadvantage is it doesn't apply to all arguments equally well, but it applies to a lot of them. So let's take a look at this argument and start to get our very first inference rule. Take a look at this. If Max is a poodle, then Max is a dog. Get used to Max. You're going to be seeing a lot of them. Max is a poodle, therefore Max is a dog. I would like you to apply the Bob method to decide if that inference is good or bad. If Bob believes if Max is a poodle, then Max is a dog, and if Bob believes Max is a poodle, how likely is Bob to believe Max is a dog? Pause the video, think, and come back when you're ready. So what do you think? We tell Bob, if Max is a poodle, then Max is a dog. And I tell Bob, there's an animal underneath my desk here, Max, he's a poodle. How likely is Bob going to be to believe that Max is a dog? Very likely. So this is valid, because not only is Bob very likely to believe Max is a dog, that was kind of understatement on my part. Bob is rationally forced to believe that Max is a dog. If Bob believes this reason and that reason, Bob cannot fail to believe the conclusion. He's logically compelled. That's what valid means. Valid is like metaphysical perfection of inferences. So let's write down the rule. When I write down the rules, I'm going to be using F to stand for the front part of the if-then, and B to stand for the back part of the if-then. So the front part is Max is a poodle. The back part is Max is a dog, because what we want is a general rule. If front, then back. Now you tell me, this next reason, what is that? Is that more like the front, more like the back, the opposite of the front, or the opposite of the back? Looks like it's exactly the front, right? Therefore, again, you tell me, what's the conclusion? Is that the front, the back, the opposite of the front, or the opposite of the back? It's the back. Therefore, B. That's valid. It also has a name. The name here is modus ponens, which I will abbreviate MP. Now, modus ponens, the name of the inference, is not something you need to remember. It's just nice to know that it has a name. And if you Google modus ponens, you can see other things that are, other examples of modus ponens. What I really want you to know is that it's valid and to be able to recognize that inference when you see it. Excellent. Let's move on. This is really fun once you get the hang of it. Take a look at this argument. If Max is a poodle, then Max is a dog. Max is a dog, so Max is a poodle. Again, if Bob believes the claim here, if Max is a poodle, then Max is a dog, and Bob believes that Max is a dog, how likely is Bob going to be to believe that Max is a poodle? I'll give you a moment to think, pause the video, and come back when you're ready. Okay, what did you decide? Well, let's imagine I tell Bob, if Max is a poodle, then Max is a dog. And Bob will say, yeah, sure, all poodles are dogs. And then I say, I have an animal sitting here under my desk. It's a dog. Max is a dog. How likely is Bob going to think, oh, well, then Max must be a poodle? I don't think very likely. He's certainly not forced, because there are lots of other kinds of dogs than poodles. There are other ways to be a dog than poodlehood. So this is going to be invalid. But let's write down the rule so that we can recognize it when we see it again and will not get tripped up. It's invalid, so I'm going to take away the smiley face. Let's write down the rule. If front, then back. Now, this next claim, what is that? Is that the front, the back, the opposite of the front, or the opposite of the back? Looks like it's the back. It's exactly the same. If Max is a poodle, then Max is a dog. Max is a dog. It's the back. Good. Therefore, what is the conclusion? Is that going to be the front, the back, the opposite of the front, or the opposite of the back? Looks like it's the front. Good. That is invalid, but oh so tempting. You might not have been tempted to make the mistake here with this content because you're very familiar with poodles and dogs, but when the subject matter of the argument gets trickier, it's exactly the kind of mistake that people are just naturally apt to make. For that reason, it also has a name. It's the fallacy, because it's a bad way of reasoning, of assuming, because it has to do with a premise that we have or an assumption that we make. Consequent. The consequent here is the back part of the if-then. Okay? So Max is a dog is the back part of the if-then. Max is a dog here, this thing I'm assuming. Fallacy of assuming. The consequent, again, I'm not going to hold you accountable for that name, but it's good to know that it has one. So we've seen one good argument, one bad inference form. Let's take a look at this one. I'll give you a moment to think. If Max is a poodle, then Max is a dog. Max is not a dog. Therefore, Max is not a poodle. If Bob believes these reasons, how likely is Bob going to believe the conclusion? I'll give you a moment. Think, pause the video, and come back when you're ready. Okay, so what did you decide? I'm talking to Bob. I say, if Max is a poodle, then Max is a dog. And Bob says, yeah, sure, right, all poodles are dogs. And I say, oh, by the way, Max, who's underneath my desk right now, not a dog. Now, will Bob think, well, maybe Max could be a poodle? Of course not. I mean, I don't know what kind of animal Bob might expect Max to be. Probably a cat. Could be a small pig. Could be a goldfish in a bag. Could be lots of things. But a poodle, Max cannot be, because I told Bob that Max is not a dog, and it's awfully hard to be a poodle without being a dog. It's impossible. So here's the rule. If front, then back, now you see why I've been asking, is it more like the front or the back or the opposite of the front or the opposite of the back? Because what is Max is not a dog? Well, it's not the front part, because the front part talks about Max being a poodle. It's not the back part, because the back part says that Max is a dog. It's the opposite of that. So I will write op Therefore, what is the conclusion? Is it the front? Is it the back? Is it the opposite of the front, or is it the opposite of the back? It's the opposite of the front, right? The front says Max is a poodle. The conclusion says Max is not a poodle. So therefore, opposite of front. This is valid. So I can take away the frowny face. It's our second valid inference form. And no surprise, it has a name too. It's modus tollens. I will abbreviate that MT. So what we have here is really, I call them the modus twins. Modus ponens and modus tollens. Ponens is going forward without negating. Tollens is going backward with negating. One more. Take a look at this argument. Ask, is it valid or invalid? Is that inference valid or invalid? Think about it, pause the video, and come back when you've decided. Okay, what do you think? I tell Bob, if Max is a poodle, then Max is a dog. And Bob says, yeah, sure, all poodles are dogs. And then I say, oh, by the way, Max, down here underneath my desk, not a poodle. How likely is Bob going to be to believe, well, then Max can't possibly be a dog? Not likely. Max could very well be a dog. Max could be a schnauzer. Max could be a chihuahua. Just a poodle. Max is not. But there's lots of other ways to be a dog than being a poodle. So this is invalid. And let's write down the rule. I tell you what, pause the video. If front, then back. Sorry about that. Pause the video and try to see if you can write the rule on your own. What's going to be the next thing, therefore the next thing, okay? Pause and come back when you're ready. Okay, here's what I have. If Max is a poodle, front, then Max is a dog, back. Max is not a poodle, the opposite of the front. Therefore, Max is not a dog, the opposite of the back. Perfect. Invalid. Right? Doesn't work. But it's the kind of thing that one is apt to think might work when the content gets trickier. So it has a name too. It's called the fallacy because it's a way of reasoning that doesn't work, of negating, because I am negating something in my second reason here. This second reason is negating something. And what am I negating? Well, I'm negating the front part, right? But the technical term for the front part is antecedent. So fallacy of negating the antecedent. Again, I'm not going to hold you accountable for these names. Just if you want to impress your friends and relatives, that's what they are called. Super. So we have seen 4 argument forms. 2 good, 2 bad. The best thing to do is just practice with these until you have them memorized, because once they're memorized, you can apply them. And we're going to do some practice of this. One thing I would want to mention is you might wonder, well, why is she saying opposite of back and opposite of front rather than not back and not front? That is because sometimes the if-then sentence itself will have negatives in them. Suppose I say, if she turns in the book on time, front part, then she will not be fined, back part, okay? Now, what would be the opposite of the back part? She is fined. You see that? So if she turns in the book on time, then she will not be fined. If front, then back. But she is fined, the opposite of the back. Therefore, she must not have turned the book on time, opposite of the front. So I'm using opposites rather than nots because it's a lot less confusing when there is a not or something equivalent to a not in the front part or in the back part, like she won't be fined. Good? Or if she did not turn the book in on time or something like that. Okay, so we have seen our argument forms. I'm going to end this video, and the next one we will practice with these. And by the way, if you're finding this a little confusing, fear not. Once you start using them, it's gonna be a lot more natural, and it's actually gonna be fun. Okay? I'll see you in the next one.